Okay, friends of class 11th. Last time we learned the two methods of vector addition, that are geometrical method and algebraic method. This is the more important one. It is the analytical method of vector addition. Okay, now what happens in this? Suppose two vectors are given to you, vector A and vector B. Okay, and you are supposed to add these two vectors. First, what we do, it is just to derive a certain conclusion that I will be using one more method of vector addition. See, these two vectors are to be added. Which two? Vector A and then vector B. Now what is this angle theta? This angle is the angle between vector A and vector B. Now you would say that, sir, why this is not the angle between vector A and vector B? Why this is the angle between vector A and vector B? Just a word of caution that if you want to know the angle between two vectors, I am repeating, if you want to know the angle between two vectors, you have to start drawing them from the same initial point. Clear? So, if I want to know the angle between vector A and vector B, I will be redrawing vector A like this. Vector B will be like this. So if this becomes vector A, this is vector B, the angle between them will be theta. I will be using triangle law to add them first, but before that I want to resolve vector B. You know what is vector resolution? Breaking the vectors into sine theta and cos theta components. So let me resolve vector B. This is how I resolve vector B. Okay, vector B is given, angle theta is given. Okay, the adjacent component will be B cos theta and the opposite component will be B sine theta. And now drawing vector A plus vector B by triangle law of vector addition, which is like this. Okay. I have just marked the points P, Q, R, S, and I have just drawn by triangle law what is vector A plus vector B. This vector will be vector A plus vector B. In short, I am calling that vector as vector R. That means vector A plus vector B is equals to vector R. And then I will be using Pythagoras Theorem to solve the question. Please note the steps now. According to Pythagoras Theorem, hypotenuse, which is PS, one side which is PR, the other side is RS. So what is PS square? PS square is PR square plus SR square. Okay. This is application of Pythagoras Theorem. Now again see, what is PR? This side, PR. PR is equals to PQ plus QR, which I have again written this. That is PQ square plus QR square. Alright, now see the next step. Don't get confused in this. This is PS square. What is PS actually? PS is vector A plus vector B. What I am calling their addition as, it is a new vector, I am calling it R. So this PS square is actually R square because this side is equals to R. Now what is PQ? It is the length of vector A. What is QR? QR is equals to what? It is B cos theta. And what is RS? RS is equals to B sine theta. So I am putting these values, A plus B cos theta whole square plus B sine theta whole square. Okay, next one is the easy explanation. What I am doing now, from here I am expanding this bracket, A plus B whole square. What is A plus B whole square? See over there, it's A square plus B square cos square theta plus 2AB cos theta. Okay, now can you see these two numbers? This is b square cos square theta, b square sin square theta, taking b square common, what is left in the bracket? Sin square theta plus cos square theta. Okay, what is the value of sin square theta plus cos square theta is equals to 1. So what you get is a square as it is, b square multiplied with 1 simply becomes b square. Then 2ab cos theta is written as it is. What is this? This is all equal to r square. Then what will be the value of r? R will be a square plus b square plus 2ab all into a square root. Okay, so if you are given the magnitude of A, magnitude of B and the angle between A and B, you can directly find the magnitude of resultant vector. But still one thing is left. A vector is not complete until you mention its magnitude as well as direction. So magnitude we have found by this equation. Direction can be given by angles. Of course, yes. So vector R is making an angle alpha with respect to A. So if I want to specify the direction of R, I have to find the value of alpha also. And it's not very difficult to find the value of alpha. Alright, this is how we find the value of tan alpha. Very good. What is tan alpha? It's opposite side by adjacent side. Okay, opposite side by, it's not the hypotenuse, it is opposite side by adjacent side. Okay, now look in the diagram. What is shown to us in the diagram is this angle alpha. Okay, what is the opposite side of angle alpha? It is b sin theta. What is the adjacent side of angle alpha? It is this side, PR. What is PR? It is a plus b cos theta, this side. Okay, so now you can easily say that this value of tan alpha is equal to opposite side by adjacent side, which is b sin theta upon a plus b cos theta. Alright, this is how we find out the value of alpha. Actually, we don't directly find the value of alpha, but it is the value of tan alpha which will be given to us. Right? But if I give you the value of tan alpha, you can tell me the value of alpha. It's very simple. Okay, if I tell you that tan alpha is equals to 1, what is value of alpha? Say 45. The same way I can find alpha if tan alpha is given to me for all possible values.